Hola. Sí. Hola. Okay, so the last one. I wanted to talk a little bit about PostgreSQL because, after all, we depend a lot on it. And in fact, we are probably using not many features of PostgreSQL. And although we support several database systems, we, in fact, end up most complex features being tested only maybe in PostgreSQL. So I think it's worth talking about it a little bit. First of all, some things that should be obvious, but sometimes we forget, me at least. One thing is that sometimes we find for complex SQL queries that SQL sucks when you have to write a long SQL code. But I think it's important to remember that SQL is not only a language. It allows us to encapsulate many complexities that are inside, many decisions that PostgreSQL is making for us. If you wanted to say, okay, let's drop SQL because it sucks, let's have just some tables and bring data with us, you would have to, for example, define if you want to join two tables, how this join is going to be done. You want to use a hash, you want to sort first and then join, store things in the database. So the good thing of SQL, it's maybe not the language itself, but the fact that it encapsulates lots of decisions that some very smart people have been working for many years to find a very good algorithm and heuristics to define when it's better to follow one path or the other. Another thing that I wanted to point about PostgreSQL is that many times PostgreSQL is compared to Oracle, which is supposed to be the place where an open source database should be able to reach someday. But sometimes I think we forget that PostgreSQL has some, maybe not unique, but very powerful features that they don't even exist in Oracle. And one of them is, for example, create table inside the transaction. In PostgreSQL, you start a transaction, you create a table, you roll back the transaction, and the table has gone. In Oracle, you start the transaction, you create the table, you abort the transaction, and the table is still there. And this is something we use daily in Tryton. When we install a new module, it installs the module, creates tables, creates indexes, and if something fails, doesn't matter. You just fix your module and just install again. Something that we are using daily and we don't value because it's been there for many, many, many years. Okay? And I'm sure that Cedric, that worked on making Tryton work on Oracle, has lots of cool things to explain about Oracle. And of course, PostgreSQL manages much more things, as you all know, complex things, locking, indexes, a storage of optimized for lots of different data types. We have the luck that we have Python on top of PostgreSQL, but the SQL language of PostgreSQL already manages very, very well time deltas and this kind of objects, and of course JSONB and this kind of stuff. And it also has something that it's worth mentioning. It's a large community. I've been following the project for many years, and at the beginning there were more people, but there was one clear leader, which is Tom Lane. But over the years, more and more companies have been having profits using PostgreSQL. And I think a lesson to learn from them is that at the beginning, there were many companies building their product on top of PostgreSQL. But most of them failed because they were not able to readapt their product to newer versions of PostgreSQL. The current community of PostgreSQL is actively, those companies are actively participating to the core and moving their features into the core of the system, which is something that we've talked today and I think yesterday about it. So, for example, Enterprise DB helped Amazon to run RDS, which is a replication system run in Amazon. And second quadrant, C2DB, for example, has their own replication database, but they are moving their technologies into the core. So just wanted to point some new features that you can find in latest version, which was out, I think, in less than a month ago, and some things that have been moving in the PostgreSQL community lately. Something that I think it will be hard for any of us in Tryton workloads to find problems is scalability. It's been improved a lot, vertical scalability. That means in a single server with multiple processors, having lots of clients making requests, the amount of code and the locks, the code blocks that are locked is very small, and I think it would be very hard for a typical workload in Tryton to have problems in this part. They've been working, it's something new in 9.6. PostgreSQL already had standby servers. This means that you have, you see this main database, and you can replicate it to another database, but you replicate all the information on real time, and with several parameters, deciding what compromises you want to make from this, okay? But in 9.6, you can have not one database, one copy of the database, but several of them, okay? So of course you can have one database in one data center and one database in another data center and have read-only queries in one of the slave databases. And something that the community is pushing forward and putting lots of resources also is Postgres foreign data wrappers. Foreign data wrappers is a way to have access to a table. You see a table in PostgreSQL, but data is being accessed into your file system, into a MongoDB database, into a MySQL database, into an Oracle database. And there's a special case for this, which is the Postgres foreign data wrapper, which is Postgres asking another Postgres server for their queries. So you can join a table from your database with a table of another PostgreSQL database. And the things that are, this is maybe interesting, but the interesting part is that they are working on the fact that you want to, imagine you have 3 tables. One is in your local server and 2 of them are in the remote server. And you join all of them. So now Postgres is able to push the join to the remote server and then get the join from the remote server and join with the new one, okay? And they're working on this kind of operations, moving the deletes to the remote server and aggregates and this kind of stuff. One of the most publicized features of 9.6 is parallel queries. PostgreSQL, I mentioned that it's quite scalable, but the problem it had, if you make one SQL query, a large one, it will only use one processor. This was like this until 9.6, where now the system is capable of using multiple processors. You can imagine that it's been an infrastructure that's been created, and it's being used by sequential scans, which is basically recording all the table, for joins and for aggregates, and more things are coming. So this means that you can have 4 cores, for example, for running a single large join and select query. It only works with selects, and it can run 4 times faster than it did with previous versions. And it's not only part of 9.6, but 9.5, 9.4, it's been integrating, I would say, almost all SQL standard. Of course, you can always find something missing, but historical things missing, which was with recursive, has been integrating the recent years. Cube rollup and grouping sets, which are very useful for database warehouses or materialized views, have been integrated. So of course there are places for improvement in materialized views, for example, but I think the database is incredibly feature complete. And of course there are things like full text search integrated, row level security, JSON-B, which is JSON optimized, binary optimized, and you can query the system. There are some people that made some benchmarks comparing with MongoDB, and they say that it can run faster than MongoDB, etc. Of course, durability, it's not part of 9.6, but previous. I guess many people don't know that you can now have checksums. So when PostgreSQL will store the information in the file system, it will have some checksums to ensure that the information is properly stored, and when you try to read it, it will check that everything is okay. So that's more security for your information. Okay. I thought it was interesting to explain just a little bit what the architecture works, because sometimes we think that PostgreSQL, the fact it's an SQL database, is gonna be slow. But in fact, what PostgreSQL does, I printed here as if it was the client. You can imagine this is the node of the server. But what it does is that all your transaction is written just like a log. And you know logs are very fast because it's sequential writing, okay? So it's written in the log and it's written in the shared memory, okay? So it's written in memory most of the time. If your database fills in RAM, it most usually won't write the disk because it won't write the structure into the disk. It will just write the log, okay? And then he will later take care of writing the structured data into structure in the database. And something to take care also when monitoring your system is that maybe you don't have a lot of shared memory assigned to PostgreSQL, but the operating system is anyway keeping your information in the memory because of the file system cache that Linux kernel is going to do for you, okay? And so what's being worked on for version 10, because they're going to change the way that version numbers are going to be kept. It's going to be 10.0, then 10.1, and then the next release it's going to be version 11, etc. One is still more work on vertical scalability, but I think we won't have problems with the scalability already, so I think it's almost impossible to have problems here. They are working on quorum commit. This means that you can have 3 slaves copying all your database to the 3 slaves, but you just ensure that 2 of them have written in, or 1 of them have written the information, okay? Before returning to the client that asked for the transaction. Logical replication, which is, as I said, the replication I explained is copying the whole database. Everything, the whole log, the log is being sent to the slaves. But with logical replication, it's moving, you can say, I want to subscribe just to 1 table of the master database, and only the information from that table is being replicated, okay? So that will be, there are already solutions outside PostgreSQL, and the one of Pidgeological is being integrated into core. It means that you have a create logical replication command directly in the SQL language. And as I said before, they are pushing more stuff into PostgreSQL, so queries are being more optimal. Okay? Both methods of replication together with PostgreSQL is, in the end, building a very distributed and complex and powerful system and scalable system with multiple nodes. SQL completeness. I personally don't find many things missing. They're working on autonomous transaction, which is a very specialized thing for writing, basically auditing logs in the database outside the transaction you're in, which is very strange for me. They are working on improving parallel queries. The first place where parallel is going to be used for writing is creating indexes. That means having multiple cores, sorting data, so you can write an index in half the time or things like that. And using parallel queries or parallel processes in index scans, which is currently not possible. Another step they are working, these are all things that are working right now, so it's probably going to be in version 10 because they are quite advanced. Asynchronous execution. I don't know if you know how a database traditionally works. Basically, you have a query, you build a tree of where you have to pick data, and then from the node, from the ending node, you start taking the rope and all nodes. This table gives you a tuple, this table gives you a tuple, and like this you join them and things like that. So especially for Postgres foreign data wrappers, databases that are outside our server, they make all the system slow because of the network transfer and the work being done on the other server. So asynchronous execution will allow to, okay, I have to join these two tables from this server, these two tables from this other server, so I can ask them, both of them at the same time to work on it. And also you can have, your tables can be, I think I've got the word here. Well, you can split your table into several tables to optimize. So in the local server, so this can be used also for asynchronous execution to parallelize scanning several tables of your server. Okay. In the durability area, it's being worked. There's some work with checking that the information in your server is correct. Heal is a way of automatically fixing bugs of when the data was written. Performance, they're working a lot on huge improvements on sorting. I've seen a patch for this constant evaluation improvements in which they reduce the count operation, which is pretty slow, to half of the time. It's a technical solution. And something that we integrated in Tryton API a lot of time ago, which is creating several records at once instead of one query per record. So they are working on something similar, which is instead of asking one tuple at a time, asking for 1,000 tuples at a time, which will make the system also much faster. As you see, most of the work is being done on scalability and performance. And so, finally, some things that we could use or we could learn from PostgreSQL. I think we could take advantage of the unaccent extension, which could allow to search for names of parties without having to write exactly the accent used. Full text search and trigram and things, these kind of features, I think is the ones that would be more beneficial. full text search is a system for indexing information just like Google inside Postgres. And trigram indexes would allow us to speed up like searches. One thing we had some discussion in the bug tracker is how to manage indexes, or which indexes should we create by default. And my question is, if we create default indexes, how are we going to overwrite those defaults in Tryton? I think it should be possible that when you have an update, if we decide that the code of the party should be indexed, but in my database I don't want to have this index, how after making an update, we ensure that I don't have the index again. Okay, so I think it's something we should work on. And something linked to the talk Copengo and me did before, which is providing tools to know what's going on in production systems. PostgreSQL has lots of tools integrated into core and some plugins, and they are improving them. In the latest version, for example, I don't know if you know PG stat activity, which is a view which tells you which connections you have, that it will tell you if one of your backends is waiting for another backend to finish, for another transaction to finish. So in 9.6, it will tell you why is it waiting, in which operation it is waiting. So I think we should try to improve these kind of things, as we said in the morning. And that's all. I don't know if you have any questions.
You talk it about full text search, but how do you see it used? Because in some way you need to have, it's useful to order the result of a query, because it gives you a kind of distance between what you are searching. Is it close to what you are searching or not? So.
You can use full text search features. For example, the stemmer. Stemming is when you have the word, I don't know, trimming, and you convert the word trimming into trim, to the root. So that could be used in some places for finding product, for example, or things like that. It's not probably the main point, however. We could have a full text search, for example, on the left, the global search of Tryton. We could use full text search there.
You gave the example of stemming, but it's linked to the language, of course.
Yeah.
The root will be. Is PostgreSQL capable of mixing in the same index records in different languages? Can we mix everything?
Yes, I think you can. The problem will be in the query. After all, you've got a field in the database, which is a list of elements. And you build this list according to your rules. So your rule can be apply this stemming for English, or you could have one column per language, or you could have a column that defines the language. And then if the user is working on English, you will search for the items in English. After all, as I said, it's a field in the database, and you can structure your index as you prefer.
Just a question about using features like text search. How can we do that and keep compliance with MySQL or
compliance?
Yeah,
you mean
today all features should work on MySQL and Postgres.
As I said, I think that most key features are only working on Some key features are only working on PostgreSQL. I think the latest, the one that is using with recursive, the accounting part. I think it's only working on, you remember? The, what we call the statement of accounts, that it's using window functions, with window function, not recursive, sorry.
The question is why we keep this, if we decide to drop support of MySQL, so we should do that, and that's it.
So far, I think it's just that it's easy to keep the compatibility, something that was written and it's working. But if we need an extra feature, we are going to stick with PostgreSQL, I guess. Because MySQL is not working correctly for big decimal. So
just saying, we are at Copenhagen, we're using the unaccent extension, so we detect if we're working with PostgreSQL, and in this case we try to install the extension, because as you said, we're using a lot. We're working with French people, and there are accents everywhere. So typically the use case
was easier
of
than
searching for
French
people.
oh yeah, we have the same problem. Is it a patch or is a module? It's a patch, I guess.
No, it's in the register of the. We got in an override of the party model. I think.
You use it only in some records, in some models?
No, it's just the installation of the extension is triggered when registering an override of party in some of our core modules.
But I think you need to unaccent the string before querying the database, don't you? And probably create the index with the unaccent parameter to be
I'd have to check, I'm not sure.
You talked about replication, hot standby, and stuff like that. I don't have a lot of experience with that, but I don't have a lot of experience with this kind of setup.
I
find
mentioned features. I'm not using it, but I think it's something that people are worried about.
Okay, I find it's always complicated to set up, and so
I think it's. When did you try it?
Just hot standby with one replication.
When? In which version? Which release?
1 year ago. But
we did that.
Making the setup is not complicated. It's the management after that. When you want to update, or if there is something, the connection is lost for a moment, or do you
of course,
catch up and...
We had a customer working with this replication, but we don't longer have the customer, so we didn't have to manage it for a long time. Setup was not difficult. There are, for Negios, you have checks that check that the slave is up to date and things like that. So, of course, there's more monitoring needs. And there are also many tools to ease the replication. They are working a lot on this kind of stuff, so it's probably going to be easier and easier.
Any more questions?
How is the unaccent search working?
One question. Do you have thought about using the page state activity view inside Tryton to monitor it? You talk about the page state activity.
Well, in fact, one of the things we set in the APM patch I mentioned in the morning is that we one of the information we add to the logs or to the top operation is the process ID of PostgreSQL. This process ID of PostgreSQL is the one that is shown to you in pagestat activity. So if you look at the logs of Tryton and you see that a given RPC call is using that process ID, you can go to Postgres and see which queries are being executed at that time. You know what I mean?
Yes, but I was referring to, instead of building something outside Tryton, just create a table query that calls page state activity and shows directly in Tryton?
Yes, you could do that. But you're usually trying to monitor, I don't know, from the console, so you have...
If you have access to the server, but if you're not, then
Oh,
I
yes,
don't know,
of
it's, what,
course.
it's only if you have thought about it, one idea.
Oh.
So give some time to the Copenhagen guys.
Okay, so indeed we had a custom field for which named an accent char, and we use it. We use it at least for the menu when we're looking in the global search for the menus, because our user didn't want to write with the accents. So that's our typical use case. And at some point we had some other fields, but we noticed it wasn't really used, so we dropped it. But well, it's
Okay.
we're using it somewhere and it works, so it could be used elsewhere, I guess.
I guess you can use, you can override the fields class and define how it should be represented in a SQL query. And so by default, it just gives you the columns, but I think you can put the call to the methods there, and you will have an action automatically added.
Unfortunately, we are going to run out of time. Maybe this is a discussion we should move. I don't know if you like to follow it to its end, or if we just say we talk about this tomorrow or the day after tomorrow. I don't know. Give me a sign. All are sleeping.
This is the sign, I think.
Who wants to continue? Oh, a lot. Nobody. So I think we close the discussion and close the unconference because we are going to be late in time. Thank you very much, Albert.